Hello, student. We are talking about the property of the mechanical of material in civil engineering on the chapter 6 of material testing. We have mentioned about the steel and the concrete and the timber. And you may see in Thailand, we use a lot of reinforced concrete and the pre-stressed concrete. That means the most popular material in Thailand uh, are the concrete and the steel. The concrete can be the reinforced concrete and the pre-stressed concrete. You will have a chance to study the design of these two materials later in your third and fourth year. And then we're talking about the timber. Timber used to be the most popular material once, especially in Southeast Asia. Timber nowadays is very expensive since the problem of deforestation impact on the amount of timber that we can cut out of the forest. And most of the people who have big timber house, they are rich nowadays, unlike 100 years ago, in which rich people used to live in the reinforced concrete structure. Things change, okay? Things change. Things always change. So you need to adjust yourself to the new thing, especially the new technology that could come, like that I mentioned about how to use the robot, how to use the technology in our civil engineering application. There are some good software such as the software called BIM, the program like Revit, okay, that's from Autodesk. You can apply for the student. You can apply for the student version for free, okay, and you have a chance to practice this kind of thing. This program, this computer program, will change the way the civil engineering work. Is going to integrate every step from the analysis, okay, analysis, past the design, and past construction management. Okay, and what you're going to involve is the step that's before this is gonna be correct. Okay, if you input the wrong data into the computer, the output to be wrong. Okay, so you got to be very careful about what you use this program. And then now come to the material that is very old one, the brick. Okay, we use the brick since the ancient times. Bricks is a kind of ceramics, actually, for the especially from the one that we produce nowadays. Is have very high strength, high durability. Okay, and the brick usually in Thailand that's come from burning the clay, okay, to reach the point that the clay melt itself and change to be the ceramic. There is still another kind of brick that we use. That's called the CMU. Is the concrete masonry, and unit. Or you know it as concrete block in Thailand. It's really popular. It's cheap. It's produced by the concrete with the cast stone, and it's very versatile. It can use in many applications, and people get used to with it. And nowadays we have some other else. It's called lightweight. Okay, concrete, masonry unit. such as the one that Ajahn Thirawas is using his research for this. Usually the lightweight masonry unit is very light and easy to build. That is advantage of it. But the strength of this concrete may be lower than the CMU and below than the clay brick. This is going to be what we are going to know about this. But this lecture mainly we going to talking about the clay brick. Okay, that's we use this in long time. Many JD in Thailand, Papathom JD in Nakhon Pathom also built by the clay brick. And brick masonry unit, in according to the STM standard, we classify the brick from its appearance into two types. Okay, one is the brick that is solid brick. The solid brick is the brick that has most of the section is solid. Very small amount of this brick is the void. So if the brick have at least 70% of its total area that taking the force, that's called the solid brick. And if you have the brick that have a lot of void in it, okay, like this called the hollow brick. If you have the net area of 70 to 35% of the total cross-sectional area that taking the force. Most of the time, hollow brick is easy to build more than the solid brick, because sometimes we can put the steel reinforcement into this hole and put the grout, okay, or U3 into it. That's going to build this hollow brick very strong. Also, hollow brick during the production, when you burn the clay, the burning will be very complete for this kind of hollow brick, since the heat, okay, can come to allow the brick. So most of the time, hollow brick is very strong. Okay, the brick is very popular in Western world, because in the Western world they used to using the stone to build a house from the ancient time. Unlike us, in the Southeast Asia or the Eastern Asia, we used to use wood to build house. You may see some of the palace of Japanese emperor. There is built by the tree, by the timber. Okay, that is kind of different culture, different material that we use. They get used to with this kind of material that's very close to the stone. And then the form of the structure change. In the Western world, the form of structure, they use what's so-called the load-bearing wall to take care of the vertical force. So they don't have column, they don't have beam, such as the one in Thailand. Our culture comes from building the house from the timber. So we need to have the beam to support the floor and transferring the force to the column. But for the Western culture, the buildings built by the brick, so the load transfer from the floor directly to the wall, such as this kind of building. Okay, and since the brick is used to sometimes build tall building, at least for this is the 3-story building. So most of the brick have the high strength, high compressive strength. Okay, so coming to the conclusion of this, the brick that have the void, okay, the hollow bricks for better burning, okay, during its manufacturing process. So the hollow bricks usually have the high strength, high stiffness, and high durability. That's due to the good manufacturing process causing by the burning of the brick. Okay, due to the void. Okay, next, this is example. This very beautiful brick structure from the University of Arizona. Is in Arizona, USA. And also this one is the house that's built from the brick. You can see the texture of this building is very beautiful. At SUT, we also have some building have this kind of texture, but the structure is not really the load-bearing structure. The brick that we use in Thailand mostly for decoration. Okay, you may go to Technopolis to see this kind of beautiful structure. When you build the brick to be the wall, you have many choices. Typically in Thailand, we use the single leaf because we mostly use this brick as the space divider between the room, okay, or making it as the partition to to divide the space into rooms. In the load-bearing structure, most of the time they built by putting the brick that's in the double layer. So most of the time this is going to be very thick wall. Thick wall is good, not only taking a lot of loading, it also can do something like a temperature insulation. That means it can protect the insides of the building from the snow, from the cold weather. Okay. Another pattern of building the load-bearing wall is the cavity wall. The cavity wall is a kind of better than the double leaf or single leaf full brick because it's the air void over here. Okay, they put the air void. For what? They put the air void for temperature insulation. The air void is some kind of to help protect the the change in the temperature between outside and inside. Okay, it will prevent the loss of during the winter. In outside it's really cold, right? And your home get the heater. It can prevent the cold weather to penetrate this wall. So the void, air void is going to be the insulation, thermal insulation. And some cavity wall they clouded. Okay, when they clouded, that means they are going to strengthening the wall, making the wall more stiffer, making the wall more higher strength. Okay, and coming into this, what's so-called a masonry? Masonry is some kind of structure that's built by assembly of the clay brick or the CMU or the lightweight CMU to specific pattern, okay, by using the mortar as the bonding agent between them. This is an example, okay. This is the mortar that's used to bond the brick, okay, used to bond the brick together. And then after that, they're going to work in one single unit. The masonry can be reinforced masonry. For this one is the reinforced masonry. They built the masonry into two layer per se, and have the gap over here so they can put the reinforcement. This is the steel reinforcement. And then they can put the grout into this void, okay, to make this wall stronger. This is the grout. Actually, what is the grout? In our civil engineering, you may use to the word of the concrete. The concrete that we have the cement, usually the Portland cement mixed with water, sand, and crushed stone. Okay, and then the crushed stone used to be and sand have very good gradation, and the proportion may be 1 cement per 2 sand per 4 cut stone by volume. And then we have the word of mortar, and the mortar is above there. Okay, the mortar is used to bond, okay, the brick together, or it's also used to pave the surface of the brick. Mortar usually is the cement plus sand. Okay, let's say this one is going to be cement plus sand and plus crushed stone. And the cloud used to be the cement plus is what's so called is going to be very fine crushed stone. Okay, it's called hinfun in Thailand. And they just mix it. They use this as the waste of the production of the crushed stone here. So usually the cloud, okay, have kind of easy to pour into a small space, because most of the element that put into the cloud is the fine element. And when you do the construction of this, most of the concrete, okay, you must use the type 1 to type 5 concrete. This is the Portland cement used for mixing the concrete. But for the mortar, most of the time, the cement production company, they have special types of this for you to buy. Okay, and most of the time it's called silica cement. Okay, silica cement is a Portland cement mixed with very fine particle of sand to make it sticky when you like to bond the brick together or to pave the fronts of the wall. Make it sticky. You know sticky, right? Okay, you know it's sticky. And it may be in the US, they put the Portland cement with lime, with sand and water, with appropriate proportion. Lime is a very good material. Yeah, some people said lime is a self-healing material. What it means is when you mix the Portland cement with lime, sand, and water and use to build it, especially in the northern or southern part of hemisphere that have very cold water. And imagine during the winter, most of the time there are rain, and when it's rain, the rain will penetrate the brick, the rain penetrate the mortar. And when it's come to the night, the temperature drop down, that rain will come to be an ice. When water change status from the water to the ice, what happens is it expands. Okay, and expansion may cause the crack of the mortar, and that's crack, okay, when the ice melt to water, it can react with the chemical in lime, and that chemical can seal the crack. That can what's called self-healing material, very special one. And this lime used in the time of Roman Greeks to build large castle, those kind of things. Brick is the brittle material. By nature, the brick comes from the production of the good clay, burning with appropriate technology. And then the clay changes to the ceramic that we just mentioned before. It's a kind of ceramic. So most of the time the brick is very brittle because its behavior is going to similar to those of the ceramics. or stone. Okay, when it's subjected to the force may cause it to crack, and the crack, when it occur, is expand very quick. That is different from the concrete. The concretes have different material, cement paste, sand, and cast stone. When cracks occur, the stress can be distributed from one part to another part. Such as the stress hit the stone can take care of the stress. So the behavior of the concrete is ductile-like material. Anyway, it has very high strength. Okay, comparable to the stone, comparable to concrete. High compressive strength, but low tensile strength. That's typical for the brittle materials such as the cast iron also. It follows STM C62 classify the bricks into 3 grades. In the US, they build a house by the brick. Okay, some brick must be used to retaining wall, retaining the soil as the retaining wall. We may have the what's so called the retaining wall that's built by the brick and have the soil here. Okay, the soil may have also water. So the brick must withstand the harsh environment by the soil, by the water. Okay, the first one we call is as the SW grade. Is the severe weathering grade. It has high corrosion resistance. It has very high strength, okay, of 20.7 megapascal at least. This is very good quality brick, okay, and it will come with a good production process. Okay, and the next one, we may use the wall, okay, if this coming into the house, and the wall may go what beyond the soil, this is soil, okay, and now it may subjected to water, the rain, it may subjected to the sunlight. Okay, this second grade is called moderate weathering brick or MW. Okay, it's medium corrosion resistant brick. It can use the outside wall. It can withstand the heat from the sunlight. It can withstand the water from the rain. Also, when the temperature drop, it can withstand freezing. These have the strength of 17.3 megapascal average. And the last one, we use this brick inside the building. You have the wall again, and then you have the slab here. This one used inside. For the big one that's used inside the structure, okay, it's going to have low corrosion resistance, and also it have low compressive strength of 10.3 at least. This kind of actually compared to what we have in Thailand is going to call it high strength also. But anyway, according to STM, brick supposed to long lasting like 50 years. So all the brick must have certain strength to take care of the force. So in conclusion, you classify the brick in accordance with you are going to use it. If the brick will be in your basement, in your foundation, subjected to the soil, subjected to the water, and any harsh environment, you're going to use the SW grade brick. And if your wall up, okay, from the soil, but it's outside the building, you may use the MW grade brick. And if you use this inside, it has no weathering, no harsh environment, no severe environment, you may use this as the NW grade brick. For the brick, if you recall from the lab that we do the compression test of the brick, right? We have the brick, okay, and then you you measure its dimension, you weight it, you determine its density, okay, density. Some of them you put it into the water to measure the water absorption of the brick, okay, and another one you put it into the compression test, and then you measure what's so-called the compressive strength. Good brick with a good production process, okay, and good handling will have high compressive strength and high durability. Why? When you have a good clay, okay, it's going to have some important mineral over there. When you burn it, that mineral can change to be the ceramic material. So with a good clay and good manufacturing process, with good firing level, the clay will change status, change it to something like a stone. And sometimes you also need to put the hole into the brick, okay, to let the burning more complete than the solid brick. That's important, okay. And typically for similar manufacturing process, big fire with higher temperature such as 1200 Celsius and longer have the higher compressive strength. This means the melting of the clay is more complete and happen more than putting it in a lower temperature and shorter time. Next, the brick is special, okay. The brick itself, when you put it in the environment that's subjected to maybe rain from the water, the rain can penetrate the brick, okay. If the brick can take a lot of water, that means it can absorb more water, so it's going to have a lot of void. Brick with higher void and higher saturation coefficient, that means it can take a lot of water, so it's going to have the high void volume. When it have high void volume, the durability and the strength of the brick going to be lower, okay, since the void cannot take the force, so lower strength. And also the void, when the water penetrate to it, and then if in the US, for example, the weather change below the freezing point, that water will freeze and the volume expand, and it can make the crack in the brick, so it's reduce the durability of the brick, okay. And in short, the brick with low water absorption and saturation coefficient, okay, is going to have less void or less pore or less small opening than the brick that has high percent of water absorption. So low water absorption is good. If the brick have low water absorption and saturation coefficient, okay, from the lesson that I mentioned before, it's going to have high strength because the void is less. There are a lot of brick material to take care of the force. And for durability, that I'm talking about the freezing effects, those kind of water inside the brick, and if the brick subjected to the sunshine, okay, that's water will change the status, also going to decay the brick. If the water forcing the volume of the ice expand, that's going to put the pressure into the brick and lower the durability of the brick. Another one that we take the initial rate of absorption. This is important because if it has high initial rate of absorption, it will affect the mortar. What is going to affect the mortar? When it has the initial rate of absorption, that means the surface of the bricks have a lot of void, even though the inside have less void, but the surface. And then this void or pore will suck the water out of the mortar. So what happens is this mortar will not have enough water for the hydration process. Hydration process going to be down, since the water just suck out the mortar, and that's going to reduce the bond between the brick and the mortar, and also it will let the water can penetrate the joints easily. And if the water can penetrate the joint easily, come from what I'm saying, under the condition of freezing, okay, that's going to expand the crack or expand the void between the brick and the mortar. And also if it have the water penetrate into it, the water may go deeper and deeper and may cause the masonry less durable. The standard of test. There is a number of tests for the brick, but mostly is a kind of not used too much, because most of the brick in Thailand we didn't use it for taking the load, or we are not use it as the load bearing structure. BAR, bearing, sorry. So we don't have a much chance to test the brick much. We didn't use in load bearing structure. And also when you take the TIS, the Thai Industrial Standard 27, you got to take the method of sampling. Okay, you got to sampling the brick following that. And there are a lot of STM that's involved with it. Actually, the TIS adopt those of STM standard for the brick, since the brick in the US have been developed for a long time. In the US, there is a society called the Masonry Society, the TMS. The Masonry Society. Okay, one of my ajahn, Professor Doctor, he is a professor for Ajahn Virapant Mattis, Professor Dr. Mattis. He is the one is established the Masonry Society. That's a big society in the US. A lot of people who working on the brick going to join this society. And the mason in the US get high salary because it's really skillful worker. And the TMS also have some training course for the mason. Okay, and the mason going to have the training, but they're going to show their skill every specific year. If their skill drop, they got to have the retrain for the mason and to get a good salary as he used to have. So some of the US people, they didn't want to go to the college or university because if there is a skillful worker, their salary is better enough and a lot of the time better than the young engineer, and their work is going to be outside of the office, and those people like it. So you have a choice of life. Okay, so finally we arrive at the advantage as disadvantage of using brick masonry in construction. There are a lot of advantages of using brick. First one is strong and is durable. Like the brick is kind like a stone and ceramic. It can take a lot of force and it can withstand a lot of weathering. It's soundproof because it's kind of stone again, so the sound from one room will not penetrate to another room. It's high fire resistant to its ability of the ceramics. It's temperature proof. It's help to transfer. It won't let the heat to transfer from one point to another point. Unlike the steel have that bad disadvantage, the transferring the temperature. So in steel structure, you're going to have 5 proving to spray on the steel, and in some cases, when the fire occur in one room, the heat can transfer to another room, and if that room has some uh, uh, easy to burn material, the other room also can burn from that heat that's transferred across the steel. It's very aesthetic for the brick. You can construct it any way, any shape, any size you like. It's up to the ability of the mason that you have. It's cheap. It's low maintenance cost. Okay, because it's kind of a ceramic. You have stone compared especially to the steel. It's very similar to the concrete. It's environmentally friendly when it's produced, and as you may see in a factory that we have in the way from Kolat to Pimai, very close to Pimai there is a big company. That is high quality big company, and sometimes we go there to bought the brick to be the example for your guide for the specimen, not example for the specimen for for your guys to test it in the lab. And it is advantage. The detail of the design of masonry is kind of a lot no complicated or complex. So analysis and design of the masonry needs a lot of detail to work on, and a lot of specification also. So like I said, it's need very skillful mason to produce a good masonry structure. So this is the first the part of the brick that you should know about it. And maybe in the near coming future, when things change, when the people change, the brick may come as a main construction material in our region. But by the time if you go to study further in the US or in the Europe or in Australia, you will have a chance to see a lot of brick structure, also brick masonry structure. That's really beautiful. Actually, I love it. Okay, next we move to the aluminum. Aluminum is a kind of material that's going to have high strength. Aluminum has high strength, and it's also very durable. It's also very durable. It can withstand a lot of weathering. Okay, and it's also can 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 withstand a lot of weathering. Nowadays, aluminum start to come to our civil engineering application more and more. I will give you the example later. Most of aluminum alloy used in the past in the aerospace industry that's going to build like the airplane. It's also used on the automotive industry to build the vehicle, some in the engine, some in special part of the vehicle, because it's also lightweight. Okay, that's very important thing. And let us start. Aluminum is in the form of aluminum alloy that we are using in our civil engineering application, and the manufacturing that's going to improve that's mechanical property for application in our civil engineering. If you may see this example of the column and the patio that's shown here, the coverway that's going to be very light and strong and very durable, but it's going to be a kind of expensive though. The good thing is the material has a high strength, as I just mentioned it before, compared to my steel lightweight. Okay, since it's lightweight, it's ease of construction and have high resistance to environment. Okay, but it's a kind of sensitive to the alkali, so you cannot put aluminum with the concrete. Okay, the concrete will destroy the aluminum easily, and it's not like some acids. That means you cannot use it in some kind of water treatment plant that have some acid in it. Okay, you cannot use in here. And you may see a lot of aluminum used nowadays, especially in some structure that's close to us. For example, they use in windows, in the frame of the window. It's the frames of the window. Okay, and it's also the frame of the door, because it can withstand rain and sunlight. It's also used in the bathroom. Okay, because it's light, it can install easily, and also it can use in many places for the aluminum. And in some structure, such as this one in Hong Kong, okay, this building is aluminum building. It's used a lot of aluminum products. It's going to be weatherproof, have high corrosion resistance, is immune to the UV, and it's used a lot of gases. So this building will have the sunlight for energy and for energy efficiency. Okay, it has a good design for the long-term basis. And from the website, it said this is not going to be expensive building because the maintenance cost is going to be low, and it can withstand a lot of extreme condition. This is one of example of modern structure, and you may see around it is built by the concrete structure. The manufacturing process of aluminum alloy, three of them. The one that's popular for us is extrusion. You pull the aluminum when it's hot, okay, passing to the heated die to build it as I as the T as the C section. And by drawing, the second one is drawing. You pour aluminum alloy again, but this one passing to the die by co-working. This is going to produce what's so-called strain hardening. Okay, most of the small structural section of aluminum alloys built by drawing, manufactured by drawing. But for the one that's used in the high-rise building, those kind of example I just mentioned usually is extrusion, is produced by extrusion. For forging, you reheat the aluminum, especially as is the plate, and then you bend, you cut to the required size. So extrusion is the most important one. And the test table will show you the type of aluminum alloy that's used in many applications. Okay, and what we are usually use is these two aluminum alloy, and you can see in many textbooks mention about these two type alloy. This mostly produced by extrusion to be the structural shape. Okay, and then is used in the main structure. There are also else that may use for the door frame, curtain wall that I just mentioned and show you the picture, or the windows. Okay, that is for non-structural application. Let's say this is going to be non-structure application. Okay, and only this is for structural application. The mechanical property, you will see this graph before. The stress strain diagram of the aluminum will follow what I'm showing you with the red line here. You can see the slope or the modulus of elasticity of the aluminum is less than the steel. Actually, it's 3 times less than the modulus of elasticity. And then the strength, the yielding of this by 0.2% offset. If you draw it like this, the yielding of the aluminum very close to those of the steel, and higher than the cast iron, higher than the wood, higher than the rubber. Okay, in short, aluminum alloy is high strength and lightweight material. High strength is lightweight material. It have a ductile behavior. It can deform a lot from this. It can deform a lot. This is 0.01 already, right? Aluminum alloy has no clear yielding. That's what I've said. You got to use the 0% offset to determine the yielding stress of this aluminum. And this table shows you different types of aluminum, and they are going to be the alloy 2024 as the example. You may see it have the tensile yield strength of 395 megapascal. That is very high compared to the steel, and it has the modulus of elasticity of 33. That is 1/3 of the modulus of elasticity of the steel. This is going to be larger than sigma square of the steel. This is only 1/3. That means when you design the aluminum structure, you're going to have what's so-called the deflection controlling, or another name is the stiffness controlling design. That's the design that you can decide the section is past the maximum moment, it passed the maximum shear, But when you check the deflection of structure will get kind of large since it has the low modulus of elasticity. So you need to redesign it, and then you get larger section. This happens is very close to those of the timber that has small or lower tensile modulus, and also very similar to the fiber reinforced plastic that we will mention this later. Okay, and now that is the end of the aluminum. The another material that have the problem about the stiffness or the design of this structure is in stiffness controlling design is the fiber reinforced plastic composite. In short, we call this as the FRP. FRP used a lot in the aerospace industry. It's used a lot in the airplane. Okay, the skin of the airplane, the interior of the airplane, those kind of things. Because this material actually come from what's so called in similar to plastic, so it's going to be light, high strength. And nowadays the FRP technology transferring to our CE application. And in our CE application, we use the punctuation process to produce the FRP with the sections such as box section, hollow section, those kind of things. And it's used a lot in the US. My dissertation also involved with this fiber reinforced plastic composite. I used to study it for the guard railing that's going to prevent the vehicle when it's out of the way and it's going to drop from the bridge. We're going to design the rail, the guard rail that's going to prevent the car when hitting the guard rail, that's going to be strong enough to maintain the car within the bridge. Won't let it go down into the water or something else under the bridge. That's going to be catastrophe. Okay, the FRP, what is this? The FRP is a composite. That means it's going to build from different material. It's going to manufacture by the fiber. The fiber have high strength, high stiffness, and then it's bond with the polymer matrix. Okay, so they're going to have no change in physical and chemical property. Thinking about the fiber as the steel reinforcement. Okay, steel reinforcement. Thinking the polymer matrix as the concrete is comparable. When they work together, the steel and the concrete have no change in physical and chemical property. And then it's going to help each other to resist the force. And the same, the mechanical property will be different from individual fiber and individual matrix. The reinforced concrete also, the behavior of the strong concrete are different from only concrete only or only steel only. It's some kind of, it's the unique property after you design them to work together at the reinforced concrete. And also very special if you think about the pre-stressed concrete, in which the steel pre-stresses first before you pour the concrete into it. That means you can design the concrete structure with some preliminary forces to resist the applied forces. That's very modern one for the PC. So thinking about reinforced concrete or pre-stressed concrete, but this thing is going to be lighter, okay, taking a lot of stresses, and it can be used in different kind of structure, because in the manufacturing you can make it in various colors, so it's going to be very beautiful. This picture shows the cross section of the fiber. This is all the fiber, okay, and it have the mat, okay, to cover it. It has the surface well. This kind of structure mostly is symmetric, and then when you put it into the matrix, the matrix gonna bond them together and making it to be a good FRP. This is one of very old examples since 1923. That's about 50 years ago. In England, they use the FRP to be the surface of this building. See, it's really gorgeous. It's look modern compared to the building besides it. And in the future, this is the possible shape of thing to come according to the SMC Alsop architect. This is architect company said the FRP material could be have in important role of this kind of building. It not be the house, but it may be like exhibition hall. Or this kind of structure may be built in the moon or the Mars if the people move there, since the manufacturing process can be done in the space. I mean the partition can done in the space. Unlike the steel, the steel industry is very heavy, is big. It won't appropriate to use outside this world. And it's also used in many ways. For this one, the FRP, the back one, used to what's so-called strengthening. Okay, this is going to be RC column. In the past, there are some earthquake hit like in the Japan and in the US, and then some column may get the earthquake force and have some damages. So you can strengthening the column by this. Or this one is strengthening for the beam. You can put the FRP, the back one, on the bottom. This one can be construct easier than the steel. In the past, they used the steel jacket. Okay, the same thing like this. If it's steel, these two people, not only two people, going to work here. 3 people actually. You got to use some kind of devices to build the steel jacket into this column. Also, this is for the beam, but this one strengthening for the shear, this one for the shear, but this one for sure for the moment. This one for compression of the column. This is a section. You may see the section of FRP can be any section, but it's going to be really similar to the steel section. You can build it with different color, so it's really colorful. It's really vibrant. Okay, let's talk about the component of the fiber reinforced plastic. The first one is a fiber. The fiber is the main component of the FRP. Is going to use to resist the force. It's the same as the steel. It's comparable of the steel. Most of the force taken by the steel in reinforced concrete, and the fiber going to take the force in the FRP. It can be separated into graphite or carbon fiber. This used mostly in the expensive structure, such as the airplane, such as the wind turbine. We got to use this. It has the high strength, high stiffness. It's good in every way, but it's expensive. Okay, it's expensive. Gas In CE, we use a lot of glass fiber because glass fiber is cheap, even though it is not strong as the graphite or the stiff as the graphite, but is appropriate use in our civil engineering application. Boron also have the high stiffness. It's not used in our CE. It's used in in the car application. The Kevlar aramide FRP used in the military industry. It can be used to produce the jacket that prevent the penetration of the bullet or the bulletproof jacket. It may be used to build to product the bulletproof jacket. Okay, it can take a lot of impact force. So you got to select a proper fiber to be used. The others are expensive. For example, they are good, but they are expensive. So we select the glass. The glass have linear elastic behavior, and it has the strength very, very high from the graph. If you can compare it, okay, the graph of the e-gas may have very high strength here. That is higher than the steel. But we didn't use gas alone, we used a fiberglass with the FRP, so the actual property of the FRP is going to be less than glass only. And it also has low modulus of elasticity for the glass fiber. But for the carbon fiber, it's good. Carbon fiber is used to strengthening the column, as I just mentioned to you, or strengthening the beam, but it is not used for the PFRP. The PFRP going to use for this civil engineering application. Okay, and the fiber, especially the glass fiber and Kevlar, have very large deformation, so it can have large deformation if failure. And the glass have this property. You got to check this with the STM standard. Thailand, the Thai industrial standard won't have specification for the glass fiber yet. The matrix mostly is the polymer and is used to transfer the force between the fiber. That is some kind of similar to the concrete in some way, and its lateral support the fiber, and it protect the fiber for corrosion environment. Okay, and it's put various color into it. Most of the matrix that's used in this application is a thermosetting matrix. There is two matrix. One is the what's so called the thermoplastic. We don't use thermoplastic in our application because thermoplastic can change property drastically under the force. That's mean no under the temperature. So we cannot use this. If we use this in the structure and going to get the sunlight all the day, okay, it can be melt. Okay, we use the thermosetting. That is very stable plastic. Its property changes a little bit due to the temperature. Due to the temperature that we typically use in our typical structure. They are vinyl ester and polyester. Okay. How about epoxy? Epoxy also used, but epoxy always or many times used with carbon. Okay. And this used in different application like this. Let me go back. Okay, like this one. This is going to use carbon fiber with epoxy. Okay, this is going to be epoxy glue also. But for this one, this is PFRP. It's going to produce mostly by glass fiber. This is by glass fiber. This one mostly produced by carbon fiber. okay, and then it's going to plus epoxy. But for us, we use glass fiber with vinyl, 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 vinyl ester, okay, for this application. So now let me show you this table of the property of polyester and vinyl ester. And again, you check it with the ASTM standard. The production of our FRP called the protrusion. The protrusion starts by the lowering rod fiber, and then there are some constant, and they put into the guide, and then they put the matrix, okay, to make the fiber wet, and then they put the surface veil on the top, and then they form the section, maybe the I or maybe the C here, okay, and then it's killing over here to make the polymer harden, and then it had a caterpillar pulling over here, and then have the saw cut. This production company this production technology can use in the space. So there is some kind of idea shipping this machine out of the space and building something in the moon or in the Mars. And the following are the standard tests that's involved with the FRP. There are tensile property tests, compressive property, fractional property, and the shear strength property. That's going to follow this. Mostly the FRP is a brittle material because most of the design of it going to put some glass fiber, and glass fiber taking care of the forces that's applied to the FRP, and when the fiber fail, the FRP fail. So it's going to have brittle material and linear elastic to failure. See, it's going to be have take the force. Okay, this is the longitudinal direction. That means what? You have the member here, you cut it this way, that is longitudinal. If you cut it this way, it's going to be the transfer. So the behavior here is longitudinal, and it can take a lot of stress. That is 450, and also it has very long, very large failure at deformation. In our design, usually for the steel, we use only this is only 0.2%. That is going to be very small. Okay, if you take the small, the stress also very small, and you have a lot of large deformation after that. So the design of this is going to be different from those of the steel, and this is strain in compression. And again, it can take a lot of forces or stress larger than the steel. So mostly if you consider the strength, and usually just check it for lengthwise, that means it's going to consider in the direction of the fiber. You have the section here, you have the fiber here, okay, and then you put the force here. So tension higher than steel, compression fractional, okay, and the bad thing is they're going to get lower E, lower E. That's a lower E. So the design of this is similar to the aluminum. The modulus of elasticity even lower than the aluminum is you compare the aluminum before this, you have the E of about 70 gigapascal. And the steel, you got 200 gigapascal. But this one you can get only 26 gigapascal because it has the plastic, okay, plastic cover with the fiber. So when it's plastic, the stiffness is going to be low. Anyway, the better thing is have very, very, very low density that is going to be like a 1,850 kilogram per cubic meter. That is 4 to 5 times lighter than the steel. So in short, the compressive tensile strength, compressive ultimate strength, and compressive and fractional stress in the lengthwise direction is higher than the yielding stress of the steel. But the compressive stress in the usually we won't use it in the transverse direction crosswise. It's called crosswise, going to be smaller. Fractional modulus is less, a lot less, 7 times less. That's mean the design going to control by the deflection. And also the GFRP have low shear strength, low shear stress. So that's mean the deformation. Oh, that's mean you got to be very careful to check the ability to take care of the shear. So you don't need much taking care for design of the maximum moment. But in the design, you got to take a good care for the Vmax. Okay, for the shear max. Also for the maximum deflection. It's going to be okay for the M. It's okay, but it's going to be very, very susceptible for these two in the design. And the other L of the E to G ratio of the structural steel is kind of the FRP is kind of higher than the steel. It's higher. It's 4 times. Okay, when the steel is just 2.6. So the deformation of the GFRP, glass fiber reinforced plastic beam, may have from the shear force also. And this equation cannot use to determine the G. And the weight is lighter. Advantage is light, is have high strength, lightweight, high corrosion resistance, high thermal conductivity, high electronic transparent. So nowadays it's used like in the cooling tower, okay, in the big building, in the wind turbine, in the structure, in the rural area, such as in the mountainous area, when you like to build a bridge, caught the water in the part of mountain. Sometimes you can fabricate it in the factory, and you can ship it by helicopter, and then you board it. Okay, fabricate it over there. That's going to be very easy, and it's very high corrosion. That's mean in the mountainous area, on the sea area. Okay, it's very, very good, and it also can be used in many specific structure, such as radome. You know the radome, radar dome. Okay, it's also low thermal conductive and low electricity. The problem is it have low modulus of elasticity, so the design will control by stiffness. It have a complication of an isotopic homogeneous material, so you got to use it in lengthwise in the LW direction. So beware about it when you use this. And low shear modulus, that means the deflection total will come from the deflection due to the moment plus the deflection due to the shear. Okay, when the temperature increase, the mechanical property of this material decrease. So that is all we have for the mechanical property of civil engineering material. Okay, bye for now, and hope you guys good luck and be able to use what I teach you here in the future. Okay, that is the end of this clip.